Hello everyone, welcome back to my YouTube channel. So now we are going to learn about moments of normal distribution. So as I told you in the before video that normal distribution contains even moments, odd moments. మనం in other distributions we did mu1, mu2, mu3, mu4 like that. But whereas in normal distribution we don't do like that. We'll do even moments, odd moments. We'll separate them. Okay. So first is even moments we'll do. Okay. Even moments. So even moments it is denoted with mu2n. Okay, so that equals to expectation of x minus expectation of x whole power 2n. Okay, as we all know that mu r equals to expectation of x minus expectation of x whole power r. So in this way only we have written this one. Okay, so that equals to expectation of x minus mu, expectation of x in the sense nothing but mean. Okay, in normal distribution mean value is nothing but mu. Okay, so mu, so x minus mu whole power 2n. So that equals to integration. So normal distribution limits are from minus infinity to plus infinity. So x minus mu whole to the power of 2n into f of x dx. Okay, nothing but expectation of x equals to integration x into f of x. No, so in this way we have written this one. Okay, so that equals to integration minus infinity to plus infinity x minus mu whole to the power of 2n f of x, in the sense we have to write the normal distribution formula 1 by sigma root 2 pi into e to the power of minus 1 by 2 into x minus mu by sigma whole square into dx. Okay, so this formula we have to write. So that equals to, now what we have to do is let this term, we have to think it as z. Z equals to x minus mu by sigma. Okay, so now differentiating on both sides, dz equals to dx by mu. Mu we are having, this is 0. Why? Because here no x term, in mu no x term, no y term, so this is 0. So x by sigma is the remaining term. So that implies dx equals to sigma dz. Okay, so hope you all understand till here. So now what we have to do is we have to substitute these values in this term. Okay, in the above term. So that equals to mu 2n equals to integration minus infinity to plus infinity. So x minus mu in the sense what we can write, z sigma we can write, isn't it? So see, x minus mu equals to z sigma or sigma z. Okay, so x minus mu is sigma z whole power 2n, whole power 2n. So 1 by sigma root 2 pi into e power minus 1 by 2 into again x minus mu by sigma means z. Z whole square. Dz, dx in the sense what? Sigma dz. Sigma dz. Okay, so this term we'll make it as a constant. So 1 by sigma root 2 pi integration minus infinity to plus infinity. So sigma z 2 power n is there, no? So sigma 2 power n also we will make as a constant. Sigma whole power 2n. Here what is the remaining term? Z power 2n into e power minus 1 into z whole square. That means z square by 2. So here sigma is having, no? So here this sigma, okay, we'll write here sigma dz. Okay, so now we'll cancel these both terms. Sigma, sigma, both the terms will get cancelled. So the remaining term is sigma whole to the power of 2n by root 2 pi integration minus infinity to plus infinity z power 2n e to the power of minus z square by 2 dz. Okay. So since it is even moments, okay, even integral, no, here we are doing even integral, no, so the integrand, okay, so if it is even function, even integral, f of z equals to f of minus z. We have to think, if it is even function, f of z equals to f of minus z. So at that time, this term will become sigma 2 power n by root 2 pi. Integration will change from 0 to infinity, and here 2 factor will be adding. Okay, when if it is even function, we have to think that these both are equal. Okay, so at that time the limits will change from 0 to infinity, and here 2 factor will come. Okay, so z power 2n into e power minus z square by 2 dz. Okay, so again we are having here one formula in order to solve this one. So now we'll see what is that formula. So we know that integration 0 to infinity x power 2n e power minus a x square dx equals to 1 into 2 into 5 and so on up to 2n minus 1 whole by 2 power n plus 1 into a power n into root of pi by a. This is the formula. Okay, this is the formula. Okay, now we have to compare this formula with this term. Okay, so here mu 2 power n equals to, we'll write here 2 sigma 2 power n, 2 sigma power 2n by root 2 pi, root 2 pi. So into, we are going to compare this term with this one, isn't it? But here z we are having, here we are having x. That is the only difference. So here z, here x, 2 power n, and e power minus a x square. Here we are having what? E to the power of minus z square by 2. That means this term we can write e power minus 1 by 2 into z square, no? So that means it will be in the form of minus e power a x square only, no? Isn't it? So that means here we are having a, in place of a we are having 1 by 2. Okay, so that means these both are same. So these both are same, no? So that's why we can write in this way. So 1 into 3 into 5 into and so on 2n minus 1 by 2 power n plus 1. A means what we here, a means what? 1 by 2, isn't it? So 1 by 2 power n into root of pi by 1 by 2, isn't it? Yeah. So that equals to here 2 sigma power 2n by root 2 pi into 1 into 3 into 5 and so on 2n minus 1 whole by 2 power n 2 power 1 into 1 by 2 power n into pi by 1 by 2. So here if you see, this 2 will numerator, denominator to numerator it will come. That means here this term will be cancelling and this term will be cancelling. This 2 pi will be cancelling. If it goes to here, this term also will be cancelled. So the remaining term will be sigma 2 power n into 1 is 1 into 3 into 5 and so on, 2n minus 1 2n minus 1. So 2n minus 1 and next 2 power n and here 2 power n. This term also will cancel. So the remaining term will be only this one. So mu 2n equals to 1 is to 3 is to 5 is to and that means into, not is to, sorry, into 2n minus 1 into sigma 2 power n. So now what we have to do is now put n equals to 1. So that implies 2 mu 2 into 1 equals to, in place of n we have to keep 1. So 2, only this term we have to do. All these terms no need. Only we have to consider this term. Okay. So 2n. 2 into 1 minus 1 sigma 2 into 1. That means 2 minus 1 is nothing but 1. Sigma 2 into 1 is 2. That means 1 into sigma square. So here we got that mu 2 equals to sigma square. Okay. So this is mu 2. Now what we have to do? Put n equals to 2. So n equals to 2 means we'll get mu 2 into 2. That equals to 2 into 2 minus 1 sigma 2 into 2. That equals to 4 minus 1 is nothing but 3 sigma power 4. So this is mu 4. Okay. So this is mu 2. This is mu 4. Okay. So hope you all understand about even moment of normal distribution. So you have to remember this formula. This formula is very important. Okay, so if you don't understand, again once watch this video so that you will understand. Okay, here no need of considering all those terms. You just consider this term itself. In this term only we have to keep. Why? Because we all know that 1, 2, 3 and so on, if it is there, we consider these as n natural numbers. That time what we'll write? N into n plus 1 by 2. Like this we'll write, no? So in this way only, if you go on like this, the nth term will be this one. So that's why no need of considering this term. You just consider only this term. But this is the basic formula. So that's why we have written like this. Okay. So I think you understand. In my next video, I'll tell about odd moments. Okay, this is very important. Okay, so don't forget to subscribe this channel, like, share. Thank you. Have a nice day.